Okay, so now we know how to do transformations. We know how to do translation. We're going to be talking about the second transformation, which is called reflection. Reflection, that kind of sounds like in the mirror, right? When you reflect, have you noticed that on the mirror, it looks like there's a wall. Let's imagine the wall, is the mirror, but then everything on one side is on the other side, right? That's kind of how it looks on the mirror. It's just everything is flipped. Like for example, let's say I had a mirror line. I'm gonna do the R, mirror line there, and let's say I had the letter R on one side. Now it looks on the other side, the letter R is flipped, right? You guys have seen that on the mirror. That's what happens. Well, that's called reflection, right? It reflects on the mirror. That's what we usually say when we speak. But yeah, on the transformation, that's reflection. It flips. Now let me show you guys something real quick. Let's say I have this. Looking at a question number 5. I come up with that. Now, what I want us to see is like, let me imagine a line. Let me see it in red. I'm gonna call this mirrored line. Okay, so imagine a line. This is a line segment. It's a mirror line. So I want to reflect this. I want to reflect the original picture over a mirror line. Boom, it's right there. Notice how it flips. Interesting though. Interesting is what if I move my line? Let's make my mirror line right there. Cool. It always reflects from one side of the mirror line to the other side. Okay. Now, what if, let me hide this pictured. What if my mirror line crosses my original pictured? Interesting. What if my mirror line goes through the middle picture? How does that reflection of that look like? Looks like this. Because technically, look, the points Q and P, I move them from one side of the mirror line to the other side. You see my Q prime, P prime? But look at my points R and S. They were on the left side of the mirror line, and I move them to the other side. So when my mirror line crosses the original picture, my two pictures are going to be overlapping. Now, what if my mirror line is diagonal? This is what we call the y equals negative x line, right? We learn how to graph lines in Algebra 1. This is the line y equals negative x because it's going down, so negative x. If it was going up, I will call that, like, what if I went diagonal like this? That is what we call the line equals y equals x. The line y equals x. Okay. But actually, I don't want to see this because this one overlaps my original picture. I don't want my pictures to be overlapping. But let me take a look at the y equals negative x. My mirror should look like this. Now, one thing I want us to do, this is how we're going to do mirror. Because here, obviously, I have my figure that it overlaps. What are we going to do when my mirror, my line, let me go horizontal. How are we going to do this? Well, we're just going to count spaces. That's really what we're going to do. Look at my point Q. The way I'm gonna do this, I'm gonna count the spaces from each of my points to the mirror line, and I'm gonna count the same distance on the other side. So for example, my point Q to the mirror line is 1, 2, 3 spaces. So on the other side, I'm gonna go 1, 2, 3 spaces. Boom, that's easy. What about my point S? From point S to the mirror line is 1 space. So on the other side, 1 space as well. I count the spaces. Now, interesting on point P. P and P prime, if you see it, it's the same point, right? Why? Because technically it was 0 spaces above the line. So it's going to be 0 spaces below the line. So when the line is horizontal, not a bad thing. It's easy to do. If my line is vertical, same idea. Let me go here. Let me go this line right here. The way I'm going to translate here, or reflect, I mean, I'm going to count my spaces. Look, R is one space from the mirror line. So it's going to be one space on the other side. Same thing with S is one space here, one space here. Looking at my point Q is 1, 2, 3, 4, 5 spaces. So let me count five on the other side. So 1, 2, 3, 4, and 5. It makes sense that it's outside of my window here. So not a big deal. What if my line is diagonal though? How am I going to do it when my line is diagonal? Well, I'm going to count spaces, but I'm going to count, oops, let me just move my line. How am I going to do this? I'm going to count spaces diagonal. So I'm just going to do my point R or R and S. We get the idea. Or let me fix this really quick here. Came off a little. I cannot center it that well, but okay. Now, how are we going to do this? I'm going to count diagonal. R is one space. Notice I'm counting spaces diagonal, so one space here. My point S is half a space, so half a space on the other side. And my point P, look, is 1, 2 and a half. So I have to count 2 and a half the other way. So there's the half, and then 1, 2. Boom. So see, I'm just going to count spaces. That's what I'm going to do for reflection. Okay, so let's take a look at our work here. Okay. First of all, I have to identify the mirror line. Okay, so with red, let me identify the mirror line. It says I'm going to reflect this across y equals 1. Hmm. I know the x-axis is pretty simple. It's the one horizontal. I know the y-axis is vertical. I know the line y equals x. Remember, if I needed to do the line equal y equals x, is this one. This is the line y equals x. If I needed to do the y equals negative x, is this line. But now, what if I had to do the y equals a number? Sometimes I might have x equals a number. Okay. For that, I'm going to use the axis, the idea of the axis. Now, if I look at the x-axis, let me take a look at the x-axis. Another name the x-axis have, so one of the name is x-axis. Another name that this line has is the y equals 0 line. Interesting. Notice I changed the letter. X-axis is y equals 0. And the reason why is because any point on that line, if you get the coordinates of any point on that line, the y value is 0. That's what happens on the x-axis. So the y equals 1 is going to look very similar to the x-axis, but it's just going to be above. So on the positive side, this is the line y equals 1. Cool. I found my mirror line. Now I'm just going to count spaces and I'm going to move everything from one side to the other side. So if I look at my point S, is one space above the mirror line. So let me count one space on the other side, and that's my point S prime. Looking at my point R, to the mirror line, I count two spaces to the mirror line. So on the other side of the mirror line, let me count two spaces as well. And that's the point R prime. Remember, all I'm doing right now is counting spaces. Look at my point Q. From point Q to the mirror line is three spaces, right? You guys see it? There's one, two, three spaces. I'm counting from Q to the mirror line. There's three spaces, so let me count three spaces on the other side. So one, two, and three. And that's going to be my point Q prime. Now my point P and point P prime is the same thing. When a point is on the mirror line, it reflects to itself because it's 0 points or up and 0 points down. I can connect my corners and I can see my picture looks the same. It looks flipped. Now, for me to answer this, I'm gonna type in the coordinates of the points given. Let me find out what are the coordinates of R prime, Q prime, P prime, and S prime. I just chose an order, and I know each of my coordinates has two values, an X and a Y value. There's a comma and a space in the center that separates my two values. And just like yesterday's homework, you have to type in each number individually. All right, so R prime, what are the coordinates of R prime? -1, -1. What about Q prime? Q prime is 3, -2. The X value is 3, the Y value is -2. What about P prime? Oh, the coordinates of P prime are 4, 1. How about the coordinates of S prime? S prime is going to be -1, 0. Good, that's it. Find the reflection line and then count the spaces. Take a look at question number 6. We're going to reflect it across the line y equals x. So y equals positive x, right? So it's going up. My line, my mirror line, I'm drawing it in red. Seems like my pictures are going to overlap a little because my mirror line goes through the original picture. Okay, count spaces. Let me count V. Let me take a look at V. I'm counting spaces diagonal. So 1, 2.5. Okay, I'm gonna count 2.5 the other way. So there's the half, and then 1, 2. This is my point V prime. How about U, the point U? Okay, well, let's count the spaces. 1, 2. So let me count two spaces on the other side, and this is my point U prime. How about T? Let me follow T. Well, I'm going to the other side, right? I count diagonal. There's one space, so T prime. And what about W? Counting diagonal, it's only half a space, so half a space on the other side. There's my W prime. Okay, let me get my coordinates. I'm gonna get V prime, U prime, T prime, and W prime. And I know I have to have two values for each. This is given. There's a comma and a space in between. That is given. I'm just going to ask you to type in the numbers. So coordinates of V prime are 4, -1. The coordinates of U prime are 5, 1. The coordinates of T prime are 1, 3. And the coordinates of W prime are 1, 0. So I gave you a rule, right? I said reflection across and then mirror line, and then you gave me the coordinates. For the remainder of the homework, I'll give you the pictured, and I expect you to write a rule. Today we're looking at reflection only. So more likely my rule for today is going to be reflection only, but for the quiz and test, I have it all mixed, so get used to it. Okay? Now, when I look at my picture here, I do see God reflected. It is important for me to find the mirror line. Now, because for the mirrored, I was using distances. The distance on the on one side has to be the distance on the other side. What I'm going to do, I'm going to compare points. So look at the points K and K prime. So like I said, I'm looking at my points K and K prime. Mark the point that is, we say it in geometry, equidistant from both points. Basically, in English, find the point that is right in between, right in the middle between K and K prime. I'm going to find this point. Look at my points J and J prime, and find the point that is right in the middle. What seems to be the same point, because from J to the point, it was 4 squares, and then to the other side, it's four as well. Okay, I get the same point. What about I and I prime? That's the point in the middle. How about L and L prime? That's the point in the middle. When we have reflection, when I get all of my points, my middle points in reflection, one interesting part in reflection is my midpoints are going to create a line. All of my midpoints are going to be linear, so going to create a line. This line that I just created, that's the mirror line. Okay, how is this line called? I see this is the y-axis here. Another name for the y-axis is x equals 0. Oh, Siri seems to be confused. Okay, the y-axis, another name for the y-axis is y equals 0. I mean, x equals 0. Notice I changed the letter. Y-axis is also called x equals 0 because this is to the left. I'm going to call this line x equals -1. If it was to the right, I would have called it positive something. So my rule for this case, I know it's reflection. So on my first thing, I'm going to choose reflection across. This is something that you guys choose. It's a list you guys choose. It's not translation. We know in this case it's reflection. And then there's another space. In the space, I want you to type in the equation of the mirror line. In my case, x equals -1. No spaces altogether, no capital X, lowercase. So this is reflection across x equals -1. Good. Let's take a look at question number 8. It looks like reflection, but what's the mirror line? I'm going to find my midpoints. And remember, if it is reflection, my midpoints do make a line. You guys will see that. So look at my T and my T prime. Right in between is that point. If I look at U and U prime, right in between is this point. And then look at S and S prime. Right in the middle is this point. Interesting is that I see the line that goes through my points. From left to right. Like we usually when we read words, we go from left to right. From left to right, it seems like it is going up. So this is the line called y equals x. That's my mirror line. So my rule for this one is going to be from the first list on the list, I'm going to choose reflection across. And then on the other space, I'm going to type the equation of this line, which is the line y equals x. So half of your homework, you had to give me the coordinates. The other half of your homework, you had to give me the rule.